Good morning, student. We have completed chapter 5, Refraction through lens. I hope you all have understood. You need lots and lots of practice. So now today I am going to start with new chapter, chapter 7, Sound. This chapter you have studied in class 9th. And how the sound is produced. You all know it. When a body vibrates and it reaches us through the vibration of the particles of surrounding medium. Thus, sound produces, it needs medium to propagate. Now, sound is like light is the form of energy. You all know light is the form of energy and it gives sensation of sight. Similarly, sound is a form of energy that can be heard and travel in waves. When matter vibrates or moves back and forth very quickly, a sound is made. Or sound waves can travel through solid, liquid or gases. For example, in the school you must have seen, like when school bell rings, parts of the bell will vibrate and creating sound. Now you are aware of this audible range of the sound that human can hear. What is the range of audibility is 20 Hz to 20,000 Hz. And upper limit decreases with age. Hertz is the unit of frequency. And ultrasound ranges above 20,000 Hz. Infrasound is below 20 Hz. Now this is just we have learned infrasonic, audible, ultrasonic. Infrasonic below 20 Hz. Audible range is 20 Hz to 20,000 Hz. And ultrasonic range is above 20,000 Hz. Now the reflection of sound. Reflection of sound you have to connect with as reflection of light. You all have learned how the reflection takes place. When the ray of light strikes on a smooth polished surface, it bounces after incident on the smooth polished surface is bounced back in the same medium. Same way, sound also. When in the figure you can see that watch is shown here, tick-tock. If the sound produced by watch and it strikes to the board, it reflects back and we can hear the sound. So reflection of sound also obeys the law of obeys the laws of reflection of light. If we compare it with in reflection of light, angle of incidence is equal to the angle of reflection. Same way here also, I is equal to R. And incident wave, reflected wave and normal all lies on the same plane. Now you come to the topic. What is echo? Echo is the sound heard after reflection. After reflection, the sound which is heard is known as echo. It is produced when two distinct sounds are heard due to the reflection of the sound at an interval of at least 0.1 second. And student here, 0.1 second is known as the time of persistence of echo. Now in the diagram you can see that observer producing the sound and that sound wave strike on the rigid surface. And the distance you can see there, the sound wave from the observer travel to the rigid surface, that is x, and after reflecting back it returned to the observer. So total distance traveled by the sound is 2x when observer heard the echo. So how to calculate the speed of sound? The speed of sound is 2d, here d is x, 2d upon t. You can take speed of sound in air if you take 344 meter per second as in this example it is taken, and the persisting time of echo is minimum 0.1 second. So speed is equal to total distance upon time, and after calculating x is equal to 17.2 meter, or if we take speed 340 meter per second, you may get x is equal to 17 meter. It means from here, student, we are getting one condition. What is this conclusion from here you got? What conclusion you got? That to hear the echo, minimum distance between the observer and the reflector should be 17 meter in air. Now one more thing here in the corner, one thing is given here. Just see, sometimes echo of the same sound is heard more than once. Such multiple echoes are known as reverberations. So you should remember this. What is the reverberation? Multiple echo is heard. When in the closed room, you produce the sound, you can hear the multiple echo. That is the reverberations. As I discussed, conditions for the formation of echo. First condition for the echo is the minimum distance between the observer and the reflector should be 17 meter. This question is very used to in for the board exam. Frequent question it is asked. Frequently one after the another year give two conditions for the formation of echo. So you may write any two conditions. Here what is first? The minimum distance between the observer and reflector of the sound should be 17 meter. Second point, the wavelength of sound should be less than the height of the reflector. That is, the reflector should be large enough. And the third condition, the intensity of sound should be large that after reflection it can reach the observer. It means the sound should be produced by the observer large enough so that it strike on the reflector and come back so that observer can hear the echo. So remember this three conditions for the echo. Now application of echoes. So application of echoes are many there, but I am just taking two. One of them is sonar, and this is also, it is asked what is sonar. So sonar is sound navigation and ranging. And this device is used to measure the depth of sea or to locate underwater objects like enemies, submarines, icebergs, shoals, etc. A sonar consists two important parts. In the figure you can see a transmitter, a receiver. While measuring the depth of sea, transmitter emits ultrasonic waves. The wave strikes the sea surface and it is reflected back in the form of echo. As we said, when the sound wave strikes on the surface, it reflects back in the same medium. So the receiver receives the echo and records the time interval. So it means we got time, and between the emission of sound and returning of the echo, the speed of ultrasonic wave in sea water is known. It is known 1450 meter per second. So depth can be calculated by using the formula, equidistance formula. D is equal to V into T upon 2, where V is 1450 meter per second and T is time calculated by the receiver. So use of echo by animals, dolphin, bats, dogs, these are the animals emit ultrasonic waves. Bats and dolphin, they emit ultrasonic waves, and these waves, let me tell you, these waves strikes on the obstacle And when these waves strikes on the obstacles, what happened? It will reflect back, and the dolphin and bats can hear the echo, and they can change their path, and they themselves protect from the enemy or any obstacle. This method is called echolocation. Now I would like to recapitulate the things. Yes, student, I would like to recapitulate all the things, and I want that the right content which I am providing you on this page, you must take note in your register. Now we have all discussed, and again I am repeating these things. Sound is a form of energy. However, unlike heat and light, sound cannot travel through vacuum. As you all know, light can travel through the vacuum. It means without medium, but sound cannot. Sound is produced by the vibration of a body in a medium. I have discussed with you audible range of frequency is 20 Hz to 20,000 Hz. Ultrasonic range is above 20,000 Hz, and infrasonic range is below 20 Hz. It should be learned by heart. Now these are the terms I am going to discuss related with the sound wave. And in class 9th, I hope you all learned this, you know it. But once again, I would like to recapitulate. Amplitude. What is amplitude? When a sound wave travels in a medium, the maximum displacement of the particle of the medium on either side of its mean position is called amplitude. And amplitude is denoted by A. We are talking about displacement. So what will be the SI unit? SI unit is meter. Now look into the sound displacement time graph I am showing over here. And here I would like to make you understand what is amplitude. This is A. This is A. Here also on either side amplitude. This is amplitude. Now time period, you all know. The time taken by the particles of medium to complete its one vibration is called the time period. And we are talking about time period. I hope you all are getting. SI unit of time is second. Yes. So T is equal to 1 upon F, where F is frequency. Now how do you define frequency? The number of vibration made by the particles of the medium in 1 second is called the frequency of the wave. And unit is Hertz. And as I have discussed here, T is equal to 1 upon F. So vice versa, F is equal to 1 upon T. Wavelength. The distance travelled by wave in one time period of the vibration of the particle of the medium is called wavelength. Now, here wavelength is the distance travelled, and this is the distance travelled between this peak, it is known as crest, and here it is trough. So this distance between any two peak, it is wavelength, or distance between two trough is known as wavelength. We are talking about distance. It means unit of wavelength is meter. Wave velocity. Distance travelled by the wave in 1 second is called the wave velocity. As you know, velocity we define displacement per unit time. Similarly, here wave velocity we are talking about. And formula is, again this formula is important. This year one question was asked on based this formula. V is equal to F lambda, where V is wave velocity, F is frequency, and lambda is wavelength. Now echo. Echo we have discussed already. The sound heard after reflection from a distance of object or obstacle after the original sound has ceased is called an echo. You must learn the correct definition as it is given. The sensation of sound persists in our ear for 0.1 second after the original sound dies off. So that this time is called persistent of hearing. As I already told you, 0.1 second. The next is reverberations. When a number of echoes of the original sound are heard and each echo being fainter than preceding ones, Such multiple echoes are called reverberations. So you must write this definition, you learn it. And condition for hearing echo. The minimum distance between the source of sound and the reflector should be at least 17 meter in air. In water it will be different. In water, student, it will be 70 meter. So you must write this in air. We are talking about the 17 meter minimum distance. The size of the reflector must be large enough as compared to the wavelength of the sound wave. Third point, the intensity of the sound should be sufficient for the reflected sound reaching the ear to be audible. Uses of echoes. Echoes find their application in sound ranging and echo depth sounding by using the ultrasonic waves. Now, ultrasonic waves, why ultrasonic waves are used? As I discussed in the slide, so where in the sonar, which waves are used? Ultrasonic. Why these waves are used? Listen, student, you need to understand why these ultrasonic waves are used. These are the properties why they are used, and this is very important question. They can travel undeviated through a long distance. They can be confined to a narrow beam. They are not easily absorbed in a medium. That is why ultrasonic waves are used. The ultrasonic waves in a medium have the same speed as the speed of audible sound wave in that medium. And I have discussed this formula, echo method, to determine the speed. V is equal to 2D upon T. So you please remember this thing, this formula, and take this note in your register. Now let me tell you, uses of echo, many more are there in the book. So you must read and learn also and underline. Read the chapter, underline the points and learn the things. Thank you. God bless you.